Hello, welcome to my Calculus 1 Project 6 presentation. And we are going to go over the definition of what is it called? Curve sketching using calculus, the problem and solution, and the references. So, and it's ready and error. What is curve sketching using calculus? Curve sketching using calculus, according to Stewart from 2015, is the process of analyzing the shape and behavior of a function's graph by applying derivatives. The first derivative helps identify critical points, showing where the function increases or decreases, and the second derivative reveals concavity and points of inflection. One real-life example I could think of is when an engineer is optimizing the design of a roller coaster. Engineers use derivatives to determine where the traction peaks, maximum, dips, minimums, and smooth transitions, points of inflection, to ensure both safety and excitement. So we are going to go over the problem that was provided in the prompt. So grab the function y equal 3x squared plus x minus 2 over x squared minus 1 by identifying A, the domain of the function, B, finding the x and y intercepts, C, finding the critical points and inflection points, D, intervals where a function is increasing and decreasing, E, extremity using the first derivative test, F, concavity with interval notions, G, asymptotes, if any, vertical asymptotes, horizontal asymptotes, and oblique asymptotes, and the end behavior of the graph. Then F, sketch the function. So step one, the function, we are going to look for the domain of the function. So with that function is undefined when the denominator is equal to 0. Therefore, we solve this. X squared minus 1 equals to 0, and then, which is the denominator, which turns into x minus 1, x plus 1 equals 0. Thus, this gives the points equals plus 1. These values are excluded from the domain since it makes the denominator 0. So, thus the domain of the function is this. Right, negative infinity, comma 1. I forgot that symbol. Negative 1, comma 1. I forgot that symbol. 1, comma infinity. Now, to find the x and y intercepts, we're going to start with the x intercepts. To find the x intercept, we're going to set y equals 0. So, we're going to turn 3x squared plus x minus 2 over x squared minus 1 equals 0 to 3x squared plus x minus 2 equals 0. So maybe after solving this quadratic formula, which is x equals negative 1 plus square root 1 plus 24 over 6 equals to negative 1 plus 5 over 6 equals to 4 over 6. And then we divide that 2 over 3 or x minus 1. Since x minus 1 is not domain, the only valid x-intercept is x equals 2 over 3. So the x-intercept is 2 over 3 comma 0. So now to find the y-intercept, we're going to set x over 0. So y equals 3 parentheses 0 squared plus 0 minus 2 over x squared minus 1, 0 squared minus 1 equals to negative 2 over negative 1. By that equals 2. So the y-intercept is 0 over 2. Now, to find critical points and inflection points, we're going to look for the first derivative. So using the quotient rule of differentiation, y derivative equals parentheses 6x plus 1, parentheses x squared minus 1 minus 3x squared plus x minus 2, parentheses 2x over 2x squared minus 1 squared. So after this, we're going to simplify this equation right here. So it should read 6x plus 1 square, x squared minus 1 minus 3x squared plus x minus 2 over 2x. When we simplify it, we'll get 3 minus 6x plus x squared minus 1 minus 6x over the power 3 plus 2x squared minus 4x. It will equal to negative x squared minus 2x minus 1. So therefore, the first derivative is y derivative equals x minus 2, negative x squared minus 2x minus 1 over parentheses x squared minus 1 to the power 2 at 1 square. Setting the numerator equal to 0 to find the critical points. So a negative x squared minus 2 x minus 1 equals 0. And then we turn that into x plus 1 squared equals 0 to x equals minus 1. Since the x minus 1 is not a domain, there are no value critical points right there. All right, now we're going up for the intervals of increase and decrease. But as there is no value points within the domain, the function's behavioral intervals will be determined by the sign versus derivative. We analyze the derivative on the following intervals, which is negative infinity, comma, minus 1, negative 1, comma, 1, and 1, comma, infinity. Check the sign y derivative on these intervals to determine whether the function is increasing or decreasing. And since we found the value critical points, there are no logos strema for this equation. So to determine the concavity, we need a second derivative. y. This will help identify where the function is concave up or concave down, when there are inflection points where the concavity changes. And we're just going to skip to since we're going to look for vertical asymptotes now. So since vertical asymptotes occur where the denominator is 0, thus the function has vertical asymptotes at x equal plus 1, and horizontal asymptotes would be limit x to infinity, 3x squared plus x minus 2 over x squared minus 1 equals 3. Therefore, the horizontal asymptote is y equals 3. Since and we're going to look for oblique asymptotes, we can't find this since the degree of the numerator and denominator are the same. And if we put all this on the graph together, it should look more or less like this. Now, as you can see, the intercept points are right there. Bada bing, bada boom. And I gotta admit, this is a beautiful graph right here. It is beautiful indeed. And if we go to our references, this is our references right here. Thank you. Link to the video. Oh, we are missing one slide. Right here. I don't know where that went. Just to show visualize of everything more put together. Which will look more or less like this. Now we can get to the references. And thank you for the video. And I'll put the link after I'm done recording. Thank you.